In this lesson, we'll be talking about FMOD programmer instruments. Programmer instruments behave almost identically with your generic single instrument, save for one critical difference. The sound that a single instrument plays is simply whichever asset file is dragged into the instrument with an FMOD, whereas a programmer instrument will play a specified file from a folder outside of your FMOD project. Why is this useful? The primary reason this can be useful is from an organizational standpoint. You may note that I said a programmer instrument will play a specified file. When telling a programmer instrument to play a sound, you will pass it either the name of the sound file or the name of a key value that references the sound file you'd like to play. What this means is that a single programmer instrument can play one of many different sounds from an external directory. The classic use for this is in building character dialogue systems. You could create a single event in FMOD for each line of dialogue, but this can very quickly get out of hand and doesn't make a whole lot of sense organizationally. Each event would need to be mixed identically, and if changes to the mix were needed, each event would also need to be adjusted independently. So what about creating a single event per character and controlling the dialogue line to play with a parameter? This is definitely a better solution, but still demands a lot of redundant manual work whenever adding or changing new lines, as well as a lot of mental abstraction when trying to decipher which line of dialogue corresponds to a given parameter value. Additionally, this method doesn't allow FMOD to split up dialogue into separate banks for a single character. To take that last example to the extreme, imagine for a minute trying to place every line of spoken dialogue that Geralt has in The Witcher 3 into a single FMOD event. That would be somewhere in the realm of 450,000 audio files. Not only would this be a nightmare to manage, but it would also require every one of those files to be loaded into memory all at once, as they would all need to be stored in the same bank. Now, this example is a bit hyperbolic, but it really highlights the strength of programmer instruments in contrast to regular events. When handling complex dialogue structures in FMOD, all we really need is a single event with a programmer instrument on it, which we can mix and add effects to that will be applied to any line of dialogue we play through that instrument. Whenever we need a new line of dialogue, we simply grab it out of the dialogue folder in our project and play it through that single event. If we need to change, add, or remove lines of dialogue from our project, we don't need to touch FMOD at all. We simply change the key value corresponding to that line of dialogue and change the sound file we include in our external dialogue folder. Programmer instruments are assigned a file to play from something called an audio table. Audio tables are simply an organizational table of all of the files within a directory or folder. We can also assign a single programmer instrument a different audio table per bank, as well as a different audio table per language or locale. What this means is splitting our programmer instrument audio into multiple banks becomes a relatively trivial task to manage, but equally, if not more importantly, language localization also becomes incredibly easy. We can have the same audio table across two different locales, but assign one of them the English dialogue lines for a character, and the other, say, the Japanese equivalent lines. If we refer to these lines using identical key names, our code doesn't even have to change in order to get this system working across both languages. This is an incredibly powerful time save for any dialogue-heavy game, but it also has creative applications. Today, instead of building a dialogue system, we're going to work on a slightly more creative application of programmer instruments, which should highlight their functionality fairly well. We are going to build a simple UI system. To start, however, we'll be hooking up some UI sounds in a more traditional manner, using a single event per action. From there, we're going to build a system for handling programmer instrument sounds. Similar to our previous lesson, this system will use FMOD callbacks. I'll be taking some time to point out the unique parts of this callback system in comparison to our event callback system from the previous lesson. From there, we'll convert our UI sounds from standard FMOD events to a single programmer instrument event. Next, we'll set up a key table for this event and create a copy of the audio files folder our programmer event points to and place a separate set of sounds in that folder. Finally, we'll set up two separate locales in FMOD and assign a UI sound folder to each of them to showcase how different sounds can be played for separate localizations using identical code and infrastructure. Let's hop over into FMOD now and set up our generic UI events. To start, let's create a folder in our Events tab for organization. We'll call this folder Generic UI. Now, let's create 5 2D action events, one for each UI sound. These don't need to be anything fancy. They're single clip one-shots, so an FMOD action will more than suffice. We will name these events UI hover, for when we hover our mouse over a button, UI start, for when we click to start our game, UI quit, for exiting our game from the UI menu, UI forward, for diving deeper into menus, and UI back, for backing out of deeper menus. Next, let's assign a sound to each of these. Feel free to create your own UI sounds if you'd like. I'll be using the sounds from the 3D GameKit demo here. If you'd like, you can also add a little bit of random volume and pitch modulation to these as well. Generally, with UI sounds, you'll want to be fairly gentle with any random modulation though. Now, let's hook up these events in our mixer and assign them to a bank. You can create a custom bank if you'd like. Let's save our project and build our changes. And now let's hop over into our main menu scene in Unity. First, if you don't have them already, add a listener into your scene and an FMOD bank loader object. Let's add our banks with our UI sounds to our bank loader on start. And let's open up our FMOD settings panel. If it isn't already, set our initialization load banks setting to none. This will be incredibly important when we start working with locales later. Now, let's take a minute to talk about Unity's event system. Unity has a built-in custom event broadcasting system that behaves similarly to the event delegates we set up in the previous lesson. This system is fairly performant inefficient, so it's not great for gameplay code, but is hyper convenient and often will be used for feature prototyping or for user interfaces. If we open up our options canvas master object and dive down into it until we find any button, you'll notice these labeled fields on the event trigger and button components under specific behaviors such as onClick with their own reactive behaviors. These are Unity events subscription fields. To utilize them, we simply drag an object or script into them and assign a function from that object or script and fill in any attached input fields. Now, whenever the encompassing action is executed, on click as an example, our assigned behavior will also be triggered. As you can see, our project is already playing a sound on click and on pointer enter on this particular button. Let's go ahead and replace these with our own custom FMOD sounds. To start, let's create a script for our custom UI function calls and place it on our Start Menu Canvas object. We'll call this script UI Audio Manager. Let's open it up and add our FMOD Unity namespace. And now let's create a private event field for each of our UI sounds. Ideally, we would forego this step and pass in the UI IDs from our event system as function inputs, but we would need to pass in exact IDs or strings and wouldn't have the ability to select them from the event browser. I prefer creating multiple functions instead and maintaining the ease of use and certainty the event browser provides. This may change with the inclusion of the event reference type in FMOD 2.02, however. But for now, let's create a single public void function for each event. We'll call these functions play UI forward, play UI back, play UI hover, play UI start, and play UI quit. We'll add a null check to each of these for safety. And because they're all 2D sounds, we can simply use the runtime manager.playOneShot function for each and pass in their respective event paths. Now with that, all we need to do is hook up these event functions in our UI canvas. To do this, let's find each of the buttons in our canvas, and in the Unity event fields, where their UI sounds already are, you can either replace those or add another field as an option. Let's drag our Start Menu Canvas object into this field, and in the drop-down to the right, we'll select our UI Audio Manager Play functions. Let's quickly assign each of these. Let's also not forget to assign our actual FMOD events in our Start Menu Canvas script. Now, let's test. Perfect. All of our FMOD UI sounds are up and working. Now, let's jump back over into FMOD Studio and talk about how to convert these to programmer instrument events. The FMOD Studio portion of this is actually relatively simple. Let's start by opening our Banks tab and right-clicking our UI Sounds bank. If you mouse down, you'll notice the option for creating a new audio table. We are only allowed one audio table per bank, but it can either be a standard audio table or a localized one. The only difference between these is a localized audio table can refer to multiple different directories depending on the current FMOD locale. This setting can be changed whenever we'd like, so we will just create a standard audio table for now. We'll name our audio table UI Audio Table, and then if we select it, you'll notice a few options appear at the bottom of our Banks tab, including a field for a directory and a toggle for including subdirectories. In order for programmer instruments to be able to find sounds to play, our audio table must point to a directory. Any sounds in this directory will be compressed into our bank when we build our FMOD project and will be assigned to our audio table. If we check the Include Subdirectories box, any child folders in that directory will also be included in our audio table. But our first step will be to set up a directory for our audio table to reference. Let's hop back over into Unity. We'll create our audio tables folder within our Unity project itself. The folder doesn't have to be inside of our Unity project, but I generally recommend the following. Do include this folder in your Unity project. This way you can track it with version control software. Name the second level of depth directory Editor, as Unity will ignore anything within a folder entitled Editor when compiling full builds of our project. Our assets will be safely in our FMOD banks at this point, so we no longer need direct access to them. In your version control software, create a separate branch for your audio table changes so the rest of your team doesn't have to pay attention to them each time you make changes to them. With that, let's create our audio table folder and an editor folder inside of it. Now inside this, we'll create our first folder for our actual audio resources. Let's name this folder Default Resources. Inside this folder, let's add a copy of each of our UI sounds we'll be using. Finally, let's grab the path to this folder. Right-click any asset within the folder and select Show in Explorer. In our Explorer window, press Ctrl-L on Windows or Command-I on Mac to show the path. Copy it, and let's jump back over into FMOD. With our audio table selected, in our Banks tab, let's paste our folder path into our source directory field. You may now notice that the preview window displays our audio files. We can listen to and scroll through them here, or if we select the View button, we can see the entire display for each of them, as well as their current key names. You'll notice that currently, their keys are simply a copy of their file names with the extension stripped out, we'll be referring to our sounds by key name, so this is a little inconvenient and can make localization more difficult. To remedy this, let's jump back into our Explorer window and create our own custom key values. To create custom key values, all we need is a text file entitled keys. Let's create this and open it up in any text editor. I'll be using Sublime Text for this, but even Notepad is okay here. Now, one per line, create a name for each key, and copy in the exact string of the file that should correspond with that key, separated by a comma. With all 5 entries, let's save this and move back into FMOD Studio. Now, with our view window open, you'll notice our file key values have all changed to what we just assigned them as. And with that, our audio table is complete. We can now move on to creating our programmer instrument itself. In the events view of our studio project, let's create a new folder and a new 2D action. We'll name this folder Programmer UI, and our action also Programmer UI, this time without a space. Let's assign this event to our UI bank and our mixer hierarchy. And then returning to the event, let's add a new programmer instrument here. Believe it or not, the studio side of our programmer instrument setup is now complete. If we want, we can drag audio tables into our programmer instrument to preview them, but this won't actually change anything with our project. Audio tables are built separately from our instrument, and this is purely for testing mix and effects levels. So how do we hook up our audio table to our instrument? The answer, event callbacks. We build a system to search our audio table for key values on event callback, and then assign the respective audio file directly to our programmer instrument and play it as a one-shot. Let's jump back into our scripts folder in Unity and create a new script for this. We'll name this script UI Programmer Audio Manager and open it. As with our previous event callback system, there's a scripting example for this in the FMOD documentation as well. First, we'll need to include the system, FMOD Unity, and runtime interoperational services namespaces. This time, the only variables we'll be needing are an event reference for our programmer instrument event and an event callback custom delegate. I'll start by creating both of these and calling them UI Programmer Sound Event and UI Callback, respectively. Also, surprisingly, the only thing we'll need to initialize on start is our delegate assignment. Everything else will be handled when a UI sound tries to play. Create a start function and assign our UI Callback delegate variable a new event callback function. We'll name this event callback function UI event callback. Now, just like last time, we'll have to create this callback function ourselves. The initial layout of this function will be basically identical to our beat and marker event callback function. We'll create a private static function that returns an FMOD result and requires an event callback type and 2 int pointer inputs. We'll call these type, instance pointer, and parameter pointer, respectively. And name our function UI event callback. We'll also need the same function tag, defining this function as an event callback. And we'll start by creating a new copy of our event instance from our instance pointer, just as before. From here, however, things start to look a little different. We'll still grab our instance user data, though we'll name it string pointer this time, and we'll be using it to capture key values from our audio table instead of timeline info from our event like last time. We also don't care about saving our user data result either. And again, like last time, we'll create a new GC handle from our user data pointer and save that handle's target as a new variable. This time, however, the handle we're being given will point to a string value rather than timeline data, so we'll call this handle string handle. Specifically, we're being passed a key value from our audio table, We'll also define our target return type as a system string and call it key, and also specify that the target object we're looking for should be a string as well. From here, we'll need to create a switch statement to handle the different event callback type actions a programmer instrument can trigger. We'll need to create a case for the creation of a programmer sound. This happens when a programmer sound is attempting to start playing, as well as destroy and destroyed cases, which happen when a programmer sound stops playing and when a programmer sound instance is about to be destroyed, respectively. We'll start from our first case when a programmer sound tries to begin playing. FMOD provides a function to load a sound into memory, which we'll be using in a bit, called createSound. This function requires an FMOD mode to set the behavior of the created sound. Let's create an FMOD mode variable called soundMode and set it equal to the bitwise OR comparison between the loop normal, create compressed sample, and non-blocking enums. This will allow our loaded sound to loop if our FMOD event loops, indicates that we should load the sound in as compressed audio, and that we should open or stream this sound asynchronously. We'll also grab our parameter variable here. In our beat event callback script, this parameter was of type timeline beat properties or timeline marker properties. This parameter, however, will be of type programmer sound properties, which simply contains the string name of our programmer sound, our sound to play, and a sub-sound index, which is used to connect audio table keys to their respective sounds. Just as with our previous lesson parameter types, we'll capture it from our parameter pointer using the Marshal class and cast it to the proper type. From here, our code splits again depending on if we're referencing our sound using a key or not. If we're not, the key passed in will be the name of our sound file, including the extension, and we can test that simply by seeing if our key contains a period. We can then attempt to create and store our sound using the core system createSound function. This function requires the path of our sound file, which is simply our streaming asset path plus our key value in this case. It also requires the sound mode we created earlier, and it outputs an FMOD sound type and a function result. An FMOD sound is the base sound type that all playing sounds in FMOD are built from. Next, we'll check to make sure our result returns an OK, and if so, we'll assign our sound to our programmer sound properties. To do this, we simply set our parameter sound to the handle for our newly created sound, and because we're using a direct file extension, we can set our sub-sound index to -1. This simply means there is no sub-sound index. Then, using the Marshal structure to pointer function again, we'll feed our parameter back through our parameter pointer. Now, if we're using a custom key value instead of the direct file extension for our programmer sound, most of this can stay the same, but there are a few key differences. Let's start by copying over our code into our else statement. The only real difference is we now have a key value instead of a direct file extension, and we need some way of grabbing our actual file from this key value. Fortunately, all of this information is stored inside the FMOD sound info structure and can be accessed through the getSoundInfo function. We'll output this info as UI sound info and also return a function result. Now, if this result is not OK, we'll break out of our else statement because it means we didn't properly find a file to match our key value. Otherwise, we can continue. From here, instead of creating a sound with a path of our key value, we can grab the actual file path from uisoundinfo.nameOrDate. In case there's any difference between our sound mode and the sound mode of the sound info, we can use a bitwise operator to combine the two. And finally, if there's any extra loading information on our sound, we need to track that by passing in a reference to our uisoundinfo.extrainfo. From here, the last change we need to make is the subsound index on our parameter. In this case, we can simply pull it from our sound info directly. And that's all we need for creating new programmer sounds. Now, in our second case, we'll worry about stopping these sounds. The first thing we'll need is our programmer sound properties again. We can simply copy this function over from our other case. Next, we'll need to grab our sound from our properties parameter. And finally, we'll release the instance of the sound just as we would normally do to an event instance. And that's all we need. There are two more quick steps, and they're both really simple. The first is, we've allocated memory for our string key handle. So in order to avoid memory leaks, we need to free this memory, but only once we're absolutely sure that we're finished with it. Fortunately, the destroyed callback type indicates that we're about to get rid of our handles to our sound event instance, so this is the perfect place to call free on our GCHandle variable. And finally, assuming everything passed up until this point, we need to return an FMOD result of OK. And with that, our event callback is complete. Now, we just have to create a function for playing our UI sounds based on a string key. Let's make this function public so we can access it in any of our Unity event fields. It should have a void return type, but we'll need to allow for a string field for our key. Let's name this function playUISound by key. The initial structure of this function will look like most manual one-shot events. We'll create and store an event instance at the start of our function, and then call start and release on the instance at the end. From here, things actually look more like our battle music initialization from the previous lesson. We'll need to allocate and pin a GC handle for our string key in memory. We'll call this string handle. Next, we'll set our user data to the contents of our string handle. And finally, we'll assign our sound instance callback to our UI callback delegate. And that's all we need. Our programmer sound should now be able to pull and play a sound based on a string key value. Let's hop back over into Unity and replace our UI Audio Manager script on our Start Menu Canvas object with our UI Programmer Audio Manager. Let's assign our programmer instrument event. Now let's go through each of our buttons and replace their Unity event hooks with our programmer sound function and assign the respective sound key value. And now let's test. Great! Now we have programmer sounds working for our UI. We can now move on to talking about FMOD locales. As I mentioned before, programmer instruments are great for dialogue localization because they can enable you to swap to different languages for your dialogue lines without changing anything in code or in FMOD. In fact, once they're set up, the only change needed is to which banks you are currently loading into the game. To demonstrate this, let's first go back to our audio tables folder and create a new folder next to our default resources called alternate resources. In this folder, add 5 more UI sounds. Again, you can create these yourself if you'd like. The ones I'll be using are some additional UI sounds I had on hand, but if you don't have any, feel free to grab some random other sounds from the 3D Game Kit project, as long as they're different from the existing UI sounds. Next, We'll duplicate our keys text document in this folder and open it up. We'll leave the key names the same, but replace the file names they're connected to with the files in this directory. Now, let's open up FMOD and right-click our audio table in our Banks tab. Select the Localized option to indicate that this audio table supports multiple locales. Now, move the path of our audio table source directory back one level so it's pointing at the parent folder of both our audio tables folders. You'll notice this has broken the preview for our audio table. This is because we don't have any locales set up for a localization yet. To set these up, go into Edit, Preferences, and click on the Assets tab. Under the Project Locales field, right-click and add locales until you have 2. Select them and name them Default and Alternate, and give the default the locale code of Default Resources, or whatever you've named your Default Resources folder, and the alternate the name of its folder name. Now, let's save and build our project. If we go back to our audio table in our Banks tab and highlight it, you'll notice we now have previews of one of the elements of one of our audio tables. Near the bottom right-hand corner of FMOD, there's a Locale tab. If we select this and change it to our other locale, we'll notice that the audio file being previewed by our audio table selection also changes. This only affects preview data. Our in-game controls for this are handled by Banks. Let's go ahead and show this off. Moving back into Unity, let's check on our bank loader object. If we view our bank options, you'll now notice some different banks. Try loading in our default resources configurations and testing the game. As you can see, it sounds exactly the same as it did before. Now let's switch our locale to our alternate locale by changing our bank from default to alternate. Now, the UI sounds we're getting are the ones from our alternate set, but they're already hooked up and split into their own bank. As I'm sure you're starting to imagine, this is incredibly powerful when pushing different versions of dialogue for your game. Not only does it simplify workflow, externalize clutter, and consolidate mixing, but it also allows for dynamic changes in our sound palettes. We do generally think of programmer instruments as tools for dialogue, but that last bit, allowing dynamic changes in sound palettes, has some pretty interesting creative applications as well. I hope you all have enjoyed these past 2 lessons and are feeling confident about starting to experiment with audio reactive systems, dialogue localization, and possibly even some of the more niche creative applications of the systems we've covered. If you have any additional questions about these lessons, please feel free to reach out on the Discord. And again, if you're interested, feel free to check out my work as well on YouTube, Twitter, and Instagram. My handle on all 3 is the same, Colin V Audio. For now, best of luck to you all.